Good morning. My name is Al Aguirre, and I am the Midwest Regional Sales Manager for Gefran, responsible for sales of our temperature controls and power controls. And welcome to this morning's presentation on the redesign of our GQ solid state relay. I do want to inform you that this presentation is being recorded and it will be available for viewing on our YouTube channel later on. And also, all of your mics have been muted, and we will accept questions via the chat feature. Go ahead and just put your questions in any time, and we'll be answering those at the end of the presentation. So let's get going here. First of all, I want to let you know that a few weeks ago we did a presentation on our new DIN style solid state relays. It was the GRS and GRS-H solid state relays. I really don't want to get into a lot of the specifications here, just to let you know that it's been a great success, and you can view this now already on our YouTube channel. Just go to YouTube and type in Gefran channel, and you'll be able to search for this particular video there. So today we're going to really talk about the GQ. Now, this is not a brand new product. This is a redesign. And it is our hockey puck style relay. Of course, it fits an industry standard footprint. They are designed as single phase devices, but they can be ganged together for 2 and 3 phase load connections. They are zero cross switching, and as you can see here, these are the ranges 15 up to 90 amps. 75 amp being a new range. In the past. This was, I think, a hole in our product offering, such that if you had to go above 50 amps, you had to jump right to 90, and in many cases that made us uncompetitive. And then you have the choice of 3 voltage ranges: 240, 480, and 600 volts. So staying with the overview, this accepts 2 types of digital control signals, either a low voltage 3 to 32 volt DC signal, or a wide ranging 20 to 260 volt AC DC signal. These have an IP20 rating, which means they're obviously designed to be used inside of an enclosure. And then there is an option also, you should know, for a MOV. So this is a metal oxide varistor to be installed inside, and this would give you additional voltage, over voltage protection. And the product is UL and CE approved. Mechanically, as you can see here by this slide, it's really considered a finger safe design. So you can see here there is a hinged cover for the load and line connections, and below that you'll have just 2 screw terminals for your line and load connections. And then the control signal comes in via a connector, and this is kind of something that's unique to Gefran. Most companies don't offer this. Not a new thing, we've always offered it, but let's just review them in case you're not familiar with this feature. Now, the part numbers are here. That's an MORS 1, 2, 3, and 4. And you do need to select which type you want when you configure the part number. So let's talk about them in detail. MORS 1 and 2 are similar in that they're both plug-in connectors. And both of them have spring-loaded terminals. And both of them protrude from the front of the face that's showing here. So the front of the SSR, these things actually stick out about 1/4 inch. The main difference, or really the only difference between these, is that the MORS 1 is for a single connection point, and the MORS 2 is for a dual connection point. So if you want to daisy chain these, either 2 or 3, to do a 2-leg or 2-phase or 3-phase switching off of the same control signal, you would use the MORS 2. The MORS 3 is also a plug-in terminal. It's only for a single connection point, and the difference here is instead of being a spring-loaded terminal, it's a screw terminal. And MRS4 is new. Now, we've always had a number 4 option. First thing you should note is that it's flush mounted, so you can see up here, it doesn't protrude from the front. That's the first thing that's different. Second thing is that it's molded in, so you don't plug this in and out. And what's new for this particular redesign is that now we're using a push-in connector. In the past, the number 4 connector had screw terminals. So, but I think people like this mode of connection more. So this slide really talks about the changes from the old to the new. So starting at the left, you can see here small dimensional change on the height. It went from 30 millimeters tall to only 27. Other than that, the width and the depth on these things is the same. The next change we made was we redesigned the LEDs. They were behind a small plastic window. Now they are not, and I think it makes it much more visible. The change after that is a little bit more, I think, important to know about. So inside the SSR, inside the relay, there's a board with the two back-to-back anti-parallel SCRs that actually do the switching of the load. And these produce heat, and we need to dissipate that heat. And the first part of that is they have to be bonded onto some type of a metal plate. And originally, the design was that they were bonded onto a copper plate, and now they're bonded onto a nickel copper alloy, and it's really to optimize the heat transfer. And then the last change is, we've already talked about it, is that number 4 control signal connection. It was always flush, and it used to be a screw terminal, and now they're push-in connectors. So I want to take a minute or so, a couple of minutes here, and talk about short circuit current ratings and why it's important to know about them. So short circuit current ratings, or commonly referred to simply as SCCR, is the fault current rating of electrical equipment components and devices. For an electrical component, the rating is sometimes referred to as the level of fault current that a component can safely withstand. Now, SCCR information allows the user to determine if components can safely withstand a high fault current when installed. So in simpler terms, SCCR is a maximum short circuit current an electrical component can safely withstand without causing shock or a fire hazard. So in essence, it's a matter of safety. Now, Gefran created a white paper dealing with the SCCR ratings in more detail, and we will be sending out a copy of that when we send a link to the recorded session. So take a look at that. It's rather short, it's only a couple of pages, but there are links there for further information. Now, previously the GQ relay had an SCCR rating of 100 kA, so it's 100,000 amps when used with the appropriate fusing as shown here. And SCCR testing for the new GK has taken a little longer than anticipated, and we didn't want to delay the release of this product. So as it stands now, the new GQ has UL and CE approval, but we are waiting still for the completion of the SCCR testing. So currently, these have a default SCCR rating of 5 kA, but don't fret. If you have a customer that requires a higher SCCR rating, there is a plan in place to provide a special execution for them. So just reach out to your RSM. We don't want to miss out on any opportunities. Of course, as soon as the SCCR rating testing is completed, we'll be getting back to all of you. So let me take a moment now to talk about temperature. As I mentioned in the presentation I did for the GRS-H, temperature is the Achilles heel of all SSRs. It's simply inherent to the way they work that they produce heat, and it's important to dissipate that heat to ensure the longevity of the device. Now, the data sheets for all of the SSRs that we sell that come mounted from the factory onto a heatsink have derating curves, and we've talked about those in the last presentation. But for those relays that we sell that don't come mounted from the factory with on a heatsink, we cannot show derating curves, but instead we show these dissipation curves. Now you may ask why, and that's actually a very good question. So when we mount the SSRs onto a heatsink, we select a heatsink with the goal of being able to switch the full rated current of that device up to 40 degrees C. Now, because these are sold without heat sinks and the customer has the option of using their own heat sink, the only thing we can do is provide these dissipation curves as a kind of a guide to choosing the right heat sink. Now, heat sink manufacturers should publish for their heat sinks what's known as a thermal resistance value. And let's take a moment to look at that. So this definition comes directly from a website for a company called The Cooling House, and they are a manufacturer of heat sinks and other thermal management devices. And I'll go ahead and just read it. I think it's pretty succinct. So thermal resistance, expressed as RTH, is an important concept in index to heat transfer calculation and product development. RTH is the ratio of temperature difference to thermal power between 2 points. And here's the key sentence. The greater the thermal resistance, the worse the heat transfer performance. Conversely, the smaller the thermal resistance, the better the heat transfer. So let's dig into that a moment. As I said, in this case, what we're looking at is a value a number that will tell you the amount of thermal resistance, and the smaller the number, in this case, the better. So what I have pictured here is the thermal resistance, or the dissipation curve, sorry, for the GQ15 relay. And if you look at it closely, as I said, our goal is to provide an SSR that will switch the full rated current at 40 degrees. So if you follow this line here, 40 degrees, and it's rated at 15 amps, that means that you would need a SSR, a heatsink, sorry, that has a thermal resistance number of 4.6 or lower. And as you can see here, we have a couple of examples where you have thermal resistance numbers that are smaller. If you have one at 4, you can actually then switch the full rated current of 15 amps at 50 degrees, so on and so forth. And if you have a number that's larger, like here, you're only switching 12.5. So again, it's just a tool to help the customer know, hey, do I have a heatsink that's going to dissipate enough heat for my application? Of course, the best way to be able to know that you have a properly sized heatsink is to use ours. So we do sell heatsinks for all of these. The table on the left shows the GQ relay, and then the corresponding heatsink that we provide with the thermal resistance value. And these are all sized to be able to switch the full rated current at 40 degrees C, as long as you follow these mounting distances here. Now, of course, your customers are going to want to know the size of these heat sinks. You will not find that information on the GQ data sheet, but if you go to the solid state relay section of our website, you'll see that there is a data sheet for solid state accessories, and that'll have now dimensional information for the heat sinks, but it also has other things in there, such as mounting hardware, thermal transfer paste, fuses, fans, things of that sort. So if you're not already familiar with it, go ahead and navigate to the section of SSRs on our website and look for that. There's a lot of neat little products in there. The ordering code is fairly straightforward. The first field obviously is the family or the series number, which is GQ. From there you pick your nominal current, 15 to 90 amps, And then the nominal voltage, you can see there's three ranges at 240, 480, and 600 volts. Just so that you know, the 15 amp relay is only available in 240 and 480 volts. You cannot purchase it in 600 volts. From there, the next field is your control voltage input, your input voltage, and it'll either be the 3 to 32 volt, so the low voltage, or the 20 to 260 volt AC/DC input. The next field is for your over voltage protection. So this will be an option to include it in the unit, or you'd have to have it on your own if you want that over voltage protection. Now, one thing I want to let you know and point out here, it mentions that the 600 volt SSRs always will have that internal MOE. So the 600 volt range GQ cannot be purchased without the internal MOV. And then last field obviously is your connector. We already talked about that. It's going to be 1 through 4. Of course, everyone always asks, so well, where do I sell these? And I can make a blanket statement and say, well, obviously anyone who's using an electric heater is a potential customer, right? But let's talk a little bit more in specifics. So if you've been a Gefran distributor for any number of years, you know that a key market for us has always been plastics, and it's the same for this product, right? So anyone who's processing plastics, so whether they have an injection molding machine or a blow molding machine or a extrusion machine or any of a number of different types of auxiliary equipment, if they have heat, it's always going to be electric heat, and of course then they would be a potential customer for you. Another industry I think would be of interest to take a look at is packaging equipment, and there's a number of different machines within this market. Obviously, things such as shrink wrapping machines, sealing bars, form, fill, and seal machines, if I can say that. Sometimes referred to as pouch machines. So these are machines that actually are used to package bulk product. The machine will actually form a pouch, seal the bottom. In many cases, it might actually fill it also. And then they have to seal the top, and both of those sealing operations require heat. And so obviously potential customers. Converting is another one that I think could be of interest. Machines such as laminators, drying machines for web drying, whether it's textiles or paper. Another one that I think could be of interest would be a screen print dryer. Think of things such as textile screen printing. So think t-shirts, t-shirt machines. There's a lot of them out there. Once that ink is put on there, they have to dry them. So that's potential. These are all machines that we could supply. Food service, we do quite a bit in food service already, but there's a big market out there that we would love to talk to, and engage you guys to go out and talk to these people. Some of the things out there, and this is again just a few, would be warming cabinets. You can see there's two pictured here. This one here is designed to be under the counter or behind the counter, and then these warming displays. You go into any grocery store now, you see that to-go food, and if it's warm food, it's got to be kept warm. These are all going to have controls and typically relays. Most of this heat, as far as I know, is all going to be electric. And then small ovens, bread ovens comes to mind. The Subway store, and I don't mean the brand, I just mean places that sell sub sandwiches are all over the place now, and most of those have their own bread ovens there, and you probably wouldn't want to go talk to the restaurant itself, but find out those manufacturers. And then ovens, and then typically we're talking the smaller ovens. I think for this product, I mean, we do have products for the larger ones, but we're thinking things like incubators, dental ovens, jewelry ovens, lab ovens, environmental chambers, kilns, and I could keep going on and on and on. So when we choose partners, we're typically choosing people that we know are in these industries. So I think to a great extent, you probably know better than us where to sell these things. So bring us some opportunities. So now that you know where to sell them, let's talk a little bit about the competitive landscape. When we were redesigning this product, we had a clear mandate to make sure that we recognized who the industry benchmarks are within each market. And I would say probably in the U.S., two of our biggest competitors are companies like Cridem and Carlo Gavazzi. There's others, Omron, and we can keep mentioning those names. But we want to make sure that we are on par with these companies based on technology and price. And I think on technology, we're there. I mean, we already had a good product. We've improved it a little bit with some of our manufacturing. I would compare it to anyone else's product. And then price. Price is something that we really had to work on because we recognize that our cost structure in the past was a challenge at times, and especially when we got into the larger OEM applications, our cost structure made it a challenge. So one of the goals with this redesign was to really sharpen our pencil and get a much better cost structure. And I think we've done a good job. We have a couple of examples here. These are list prices. The first one is for a 25 amp 240 volt unit. You see the price went from 41 with the older unit to 3250, which is significant. And the next one is for a 50 amp relay with an AC signal. It went from $75 to $60, so significant cost savings. And another thing which is going to make us much more competitive is that we now offer that 75 amp range. As I said in the past, if we had to go above 50 amps, we immediately had to jump to 90, and that of course made us higher than competitors. So all in all, I think we've done a good job. We've still kept really good quality. I mean, the cost savings were done through automation, through better buying, through other cost saving measures, and it's really a good product. So I have to tell you that just as this product was being announced, we got an inquiry from through a distributor for a yearly buy at a large end user. 500 relays they usually buy a year. They go through that many. And we had bid on this in the past and had never gotten it. And with the new cost structure, we got that order and we're able to deliver within a few weeks. So keep that in mind. The cost structure is there, bring us opportunities. We are encouraging all our distributors to stock these, especially for the MRO type business. You know, as you know, in the MRO, when the customer needs to replace SSRs, the name of the game is stock. If you don't have it on the shelf, you're not going to get the order. So just based on our own experience and also industry statistics, we know that the bulk of uses, or the bulk of the SSRs, are in the 20 to 50 amp range. So if you were to put some in stock, that's where you want to be. That's kind of the sweet spot. And I would suggest ordering them in a 480 volt range. Obviously, that'll cover the 240 volt, and 600 volt is available, but not as common. And bring us opportunities. Talk to your regional sales manager. We're here to help you succeed. So next, I want to talk about what's available to help you sell this. So this slide really talks about the tools that are out there. If you're familiar with our website, which I hope you are, the screenshot on the left is familiar to you. It's the product detail page for the GQ, and at the bottom there, you'll see that there are a number of things you can download, such as 2 and 3D files, brochures. Now that brochure covers the full range of products, not the GQ only, and of course a data sheet, which you can see pictured just to the right of it, and user manuals. The data sheet is extensive. I think it's 12 or 13 pages. We know that sometimes for the distributor salesperson who's on the road, you may not want to always carry a large data sheet. And we are working on a small flyer. I think it's either going to be 2 or 4 pages. We have these types of flyers on a lot of our other products already. These are going to be flyers that have enough information on them, but you can present the product and actually allow you to make up configure a part number and get pricing. And as long as we're talking about pricing, I want to point out again, if you're not familiar with it, please make sure you are familiar with it. Our new online price configurator and inventory list. And as a salesman, if you're not using these, I would say you should get familiar with it. A lot of time and energy and money was spent on developing this to make doing business with Gefran that much easier. This was released earlier this summer, and it's available to all of our partners. You do need credentials, so you need a username and password. Reach out to your regional sales manager if you don't already have that, or if you're not sure how to use it. A couple of the features: first of all, there is a configure around there, so you can actually configure products by answering a few questions, and it'll give you a part number. And then as long as you have the credentials, you can get list pricing, and then you can check stock. And the nice thing about the stock feature is that if it's not in stock, we'll actually make recommendations for other products that are going to be similar that you might be able to use that are in stock. So that's a great feature. And to me, the best thing about this is you can actually access this from a smartphone. So if you're out with a customer and they're looking for a relay, you can whip out your phone and give them a price right then and there, and hopefully walk out with an order. So talking about the website and talking about electric heat loads, I wanted to let you know that again, I pointed this out, but Gefran has a wide variety of products, and I would say when it comes to heat, we really know electric heat. So these are the two category pages. The left one is for the solid state relays, and the right is for the power controls. Now within Gefran, we use the term solid state relay to refer to the simpler devices. You can see here, these are going to be zero cross only. Most of them have a digital control signal, though there is one model with an analog signal. And they may have some diagnostics, but it will be limited diagnostics. And again, they're going to be simpler devices, of course, lower cost as compared to the power controls. Now, the power controls within Gefran, we use that term to refer to a microprocessor-based device that has many more features. First of all of these have multiple firing modes that you can select, and most of them are going to have zero cross, phase angle, burst fire, and have single cycle. We're not going to talk about what those are, but it gives you more flexibility in how you manage a load. At a minimum, they're going to have Modbus RTU, but then a lot of them also have field bus communications options. So now you're talking about controlling these from your PLC or communicating with your PLC via either Ethernet IP or Profibus or Profinet. And then they have a lot of diagnostics and feedback. So, and today I just really want to make you aware that if you're not already, we have really a wide variety of devices for controlling those electric heat loads. Not that we cannot do other loads such as gas burners or steam, but in this area we can do quite a bit for you, not only on the temperature control side, but also on switching the heat load itself. And to that end, again, I want to let you know or remind you that we do have a channel, a Gefran channel on YouTube. The screenshot on the left is the opening page for our channel on YouTube. And at last count, we had, I think, about 100 videos just in English. There's more there, but there's other languages. And these can range from short how-to videos, and in other words, how to do specific things on a controller. It could just be overview videos on product launches. And then during this whole summer, during the COVID lockdown, we were doing quite a few product webinars. Most of these are about half an hour long, and those can also be found on our website. And I wanted to point out two of these in particular. The first one there that I want to talk about is a webinar that was done on our GTF power controllers. It was done earlier this summer, maybe July, August timeframe. At about half an hour, it goes into depth on the GTF power controls. And then the other presentation you may want to take a look at was recorded a couple of years ago, but it's still relevant. It was more of an overview, so it doesn't get into as much detail as the GTF presentation. Again, that one's about a half hour long, and it's really an overview on the range of power control products we have. And so with that, I thank you for your time, and we are now going to see what questions we have and help you out.